to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about long polynomial division, and the description is kind of in the name. It's a bit long. I'm not going to lie to you. I'm going to tell you that right up front. Long polynomial division is just one way to solve these problems. We're not really so much solving. We're more simplifying. There is a very clear shorter way, and it's called synthetic division. I also have a video explaining synthetic division which is a way to simplify these same types of problems. That's more my preferred method when I'm solving them because it's way shorter. If you're just looking for the shortest method, I'm gonna link the synthetic division to the top of this video so that you can check that one out. But if you're specifically wanting to know long polynomial division, or long division is just something that connects with you, then absolutely this is the video for you. So when we say long polynomial division, what we're doing is we're taking two polynomials, like here, right? Two polynomials, and we're dividing them. Sometimes your teachers will specifically give you examples that are factorable. And in that case, you don't want to use long division. There's a much shorter way. For example, I've kind of done this one up here on the side. So if you had x squared minus 3x plus 2 divided by x minus 1, the way you would typically want to solve these problems is to check if they're factorable. I don't like seeing it written like this. That's just a personal preference. I like to see it like this. So x squared minus 3x plus 2 divided by x minus 1. And I like to see it that way because we're going to be able to easily tell what we can cancel. We would want to factor the top, or factor anything that we can, which in this case is just the numerator. Build my little x, and I'd say, okay, what's a times c? This is going back to just basic traditional factoring. So we'd say, okay, 1 times positive 2, which is just 2, positive 2, and then on the bottom we'd have a negative 3. And we'd say, okay, my signs have to both be negative because they multiply and give me a positive. So I'd have I'd say, okay, what numbers multiply to give me 2, but add to give me negative 3? And the numbers in this case would be negative 2 and negative 1. And if you're like, I have no idea what you just did there, you're going to want to stop and review our factoring video because that's definitely stuff you want to know. But moving forward with this one, we would then rewrite this factored polynomial as x minus 2, x minus 1, using our two new numbers that we found. And then on the denominator, we have x minus 1. And at this point, hopefully you notice that we have two like terms. So we've got x minus 1 and x minus 1, and we could cancel those. And so we can simplify this division by just making it x minus 2. That's the simplified version when we divide those two polynomials. So that's the ideal situation when you can factor, cross stuff out, reduce quickly. For long division examples, this is where we can't factor. In this case, we've got an x squared plus 7x minus 9 divided by x plus 1. So you could rewrite it just like how I did here, but I just want to show you that if we try to factor this trinomial, let me try to do it just over here. So we'd end up with a 1 times negative 9 is negative 9. And then we'd end up with a positive 7 on the bottom. And we'd want to find, okay, which two factors would multiply to give me negative 9 and add to give me 7. And if you're scratching your head trying to think, okay, what multiplies to give me negative 9? There's nothing, right? There's nothing that's going to multiply to give you negative 9 and add to give you 7. So this is not factorable. Okay, so when that happens, we want to use long polynomial division or synthetic division, whichever one you prefer. Now that we've kind of figured out when we need to use long polynomial division, let's do a quick review on just your old school 4th grade, 5th grade long division. So I've written an example over here. So we've got 534 divided by 13. So we're going to do this without a calculator. Let's rewrite this how we typically would see it with long division. So we'd have 534 divided by 13. So we build that little house. And then we'd say, okay, does 13 go into 5? Not evenly, right? Because 13 is way bigger than 5, so there's no way that works. So then we're told to say, okay, does 13 go into 53? And then you think, well, and if you don't know your factors of 13, you might want to do some multiplication on the side. But I know 13 times 2 is 26. 13 times 3 would give me 39, and then 13 times 4 would actually give me 52. So if I go all the way up to 13 times 5, then I'm way over, right? So I would want to say, okay, I know 13 can go into 53 4 times. And then we'd say, okay, we multiply this number by this number, 52. And then remember that we take that and we subtract them. So we say, okay, 53 minus 52. So 53 minus 52 is a positive 1. And then remember, we look at the next number and we bring it down. And we bring that 4 to sit beside the 1. And then we say, okay, how many times does 13 go into 14? And hopefully you're thinking, well, just one time. So it goes one time. We write that up top. And then we do the process again. So then we say, okay, 1 times 13 is 13, and then we subtract. Now 14 minus 13 is 1. And then we would keep bringing stuff down if there was more to bring down, but now we're at the end of the line. So at this point, I have a remainder of 1. Our answer would be 41 with a remainder of, and remember we always write the remainder as the numerator, and the denominator as what we were dividing by. 534 divided by 13 is 41 and 1/13. So that 1/13 is that remainder. So when we do long polynomial division, we are going to follow these exact same steps. We have x squared plus 7x minus 9 divided by x plus 1. We tried to factor it, we couldn't, so we're going to move forward with our long polynomial division. We would write first our x squared plus 7x minus 9, and we are going to divide it by x plus 1. So we're always going to be dividing by this x, this first term. X squared divided by just this x. How many times does this go into this, right? So we do that kind of over on the side. So over on the side, I'm just going to do x squared divided by just the x. This is really an x to the first. And so remember, when we divide with exponents, we subtract the exponents top to bottom. Our base stays the same. And then we say, okay, 2 minus 1, which is just 1. So you can write x to the first, or you can just write x, totally up to you. I'm just going to write x. So now we multiply. Just like here, we're following these same steps. So we wrote our answer, and now we say 4 times 13 is 52, but this time we're going to do x times x would give me x squared. And I've also got to multiply the second part of the binomial now. So now I am including that plus 1. X times plus 1 is just a 1x. At this point, remember how we said, okay, we did 4 times 13 and we got 52, and then we say, and now we subtract it. We want to take this whole binomial and subtract it. We're going to subtract just straight down. We've got x squared minus x squared. And hopefully you're thinking, well, that'd be 0, right? That cancels. X squared minus x squared is 0. And if you do this right, that first term should always cancel every single time. If it does not cancel, you've done something wrong. We need to go back and check our work. Now let's do the second term. So we've got a positive 7x minus x, minus 1x. So in that case, it's just 6x. And now just like we brought that 4 down in that problem, we're going to bring this negative 9 down. and we start the process again. So now we say, instead of jumping here, we're going to jump down here. We're going to say, okay, what is 6x divided by x, right? And we do that kind of over on the side. It's just easiest, I think, than trying to do it in your head. So we write 6x divided by x. Now, hopefully you notice that that's an x divided by x, and that cancels. So we're just left with 6. All right, so we know that 6x divided by x is a positive 6. And now we multiply it out. So we say 6 times x is 6x. 6 times 1 is positive 6. We've got to subtract it. Don't forget your parentheses, okay? So we are subtracting that whole bottom part. So what's 6x minus 6x? Well, again, we should cancel if you've done your job right. 6x minus 6x is 0. Now we've got a negative 9 minus 6, a negative 15. Now at this point, if I had something further to bring down, I would, but I don't. So that means I have a remainder of negative 15. Just like over here, we had the remainder of 1. So we're going to rewrite our answer just like how we wrote this answer. It's just going to look a little bit more complicated, but it's really the same thing. So we're going to rewrite this as the actual answer we got up here, so x plus 6. Now we're going to include our remainder. So we're going to do the actual number we got in the numerator, so negative 15. And in the denominator, we're going to put, just like we put 13, we're going to put x plus 1. And that is your simplified answer. Let's look at the second example. Notice that this is a 4-term polynomial, and the way we would traditionally factor a 4-term polynomial is to do factor by grouping. I've done a video on that before. In this case right here, remember for factor by grouping, we always want to factor out the GCF and then hopefully we end up with twins. So let me show you what I mean. I'm going to try to do it here. We would say, okay, well, let me do the first group. Right? And let me find the GCF of that group. And then let me take the second group and I'll find the GCF of that group. So positive 5x plus 1. We're going to split this into 2 separate groups. And we'd say, okay, what's our GCF of the first group? Well, we've got a 2 and a negative 7. They don't have a GCF other than 1. So then we'd say, okay, we got 3 x's and 2 x's. So my GCF is x squared, right? And then we actually divide out that x squared. So then we'd say, okay, 2x cubed divided by x squared. Well, that's 2x, and negative 7x squared divided by x squared, those would cancel, and then we just have minus 7. Okay, so far so good. But then when we try this one, remember we always factor out that leading positive sign, and we'd say, okay, the GCF between 5x and 1, well, that's just 1, right? There's nothing I can pull out other than that. So that's okay. Let's just divide out that 1 and see what we have. So positive 5x divided by 1 is just 5x, and 1 divided by 1 is just 1. Herein lies the problem. In traditional factor by grouping, if you've done your job right, you would end up with twins here. We've done our job right, and we didn't end up with twins. So this is a situation where factor by grouping wouldn't work, and we need to use long polynomial division. So we've got a 2x cubed minus 7x squared plus 5x plus 1. And that divided by x minus 2. We start just like we did here. We start with this first term and we say, okay, what's 2x cubed divided by just the x? So let's do that on the side. So 2x cubed divided by x. So just like we talked about here with our exponent rules, this would end up being 2 divided by 1 is 2. X cubed divided by x is x squared, right? That's that 3 minus 1 is 2. So we end up with 2x squared. Now, just like we did here, we're going to multiply it out. So 2x squared times x is 2x cubed. And 2x squared times negative 2 is a negative 4x squared. We want to subtract that. So now let's do it. 2x cubed minus 2x cubed cancels, as it should. And then we've got a negative 7x squared minus negative 4x squared. We got to be really careful there. That's a lot of negatives. Remember, a negative and a negative make a positive. So really it's like saying negative 7 plus 4, which would give us a negative 3. And then we've got our x squared. And then we bring down the next term. So we'll bring down our plus 5x. And we start the process all over. So now we say, okay, how many times does x go into negative 3x squared? And we do that over on the side. So negative 3x squared divided by x. And that leaves us with a negative 3. Remember, 2 minus 1 is just 1. So we're left with a negative 3x. Let's multiply it out. So negative 3x times x is negative 3x squared. And negative 3x times negative 2, that becomes a positive 6x. Even though that minus is there, that does not count as our subtraction. We need to, in addition to that, right, add our subtraction because we are subtracting this whole thing. So be careful. So what's negative 3x squared minus negative 3x squared? Well, remember, two minuses make a plus. So that's like saying negative 3 plus 3, which cancels to 0, as it should. And then we've got our 5 minus 6x, which would leave me with a negative x, or negative 1x, however you want to see it. All right, let's bring down our next term. So we're bringing down this time a positive 1, and we start the process all over again. You see why this is called long division. We say, all right, negative 1x divided by x, and negative 1x divided by x is a negative 1. Those x's cancel out. So we say negative 1 up here, and now let's multiply it out. So negative 1 times x is negative 1x, and negative 1 times negative 2 is a positive 2. We're subtracting the whole thing. Negative 1 plus 1 cancels, as it should. And 1 minus 2, well, that leaves us with a negative 1. Now, if I had something else to keep bringing down, I would. I don't, okay? So that tells me I've got a remainder of negative 1. So remember, we write our top. So we say, okay, 2x squared minus 3x minus 1. And now we need to include the remainder. So we say a remainder of negative 1 over x minus 2. And that would be our simplified answer. Okay, let's do a couple more examples. There's an important observation that I hope that you'll make for both of these examples. For the first two examples we did on the other page, you'll notice that it started with like either an x squared or an x cubed, and then it hit every single exponent as it went down. So for example, it started with an x squared, then it went to an x to the first, and then our constant. This one starts x to the fourth, then goes x to the third, then goes x to the first. So where's x squared? And when you have an exponent missing like that, we have to include it when we rewrite our long polynomial division. I'm not going to take the time to try to factor by grouping on this one. I'll just go ahead and tell you when you do it, you don't get twins, so we can't do factor by grouping. So we need to proceed with long polynomial division. 7x to the fourth minus 5x cubed. So far we've got 4, 3. Now we have to include the x squared even though we don't see it in the actual problem. So here's how we do that. We do a plus 0x squared. And it's really important. If we don't have that, our problem will not work out properly. Now we pick back up with the minus x plus 4. Now we've got 4, 3, 2, 1, and then the constant, so we're good. And we're going to divide that by x plus 2. And now we're ready to go just like with the other problems. Remember, we start with our 7x to the 4th, and we are dividing it by x. So we'll do that over on the side. So that leaves us with 7, and then 4 minus 1 is 3, so 7x to the 3rd. Then we want to multiply it out. So 7x to the 3rd times x is 7x to the 4th. 7x to the 3rd times positive 2 is a positive 14x to the 3rd. 7x to the 4th minus 7x to the 4th cancels. Negative 5x cubed minus 14x cubed is going to give us a negative 19x cubed. And then we bring down this positive or plus 0x squared. And now we start the process over. So we do negative 19x cubed divided by x. So we end up with a negative 19x squared. 3 minus 1 is 2. So we write that up here, negative 19x squared. We multiply it out now. Negative 19x squared times x, that gives us a negative 19x cubed. And a negative 19x squared times 2, that's going to give us a negative 38x squared. We subtract the whole thing. So negative 19x cubed minus a negative 19x cubed, that's really a plus there, so those cancel. So now we've got our 0x squared minus negative 38x squared. So that's actually a positive 38x squared. We now take this minus x and we bring it down right here. We start the process over again. So we've got a 38x squared divided by x. And that would give us a 38x, right? 2 minus 1 is just 1. So we have a positive 38x, and we'll multiply it out. So positive 38x times x is positive 38x squared. And then we have our 38x times 2, which would actually give us a 76. So that's a positive 76x. And we subtract the whole thing. So 38x squared minus 38x squared cancels. And then we've got a negative x minus 76x. So it's like a negative 1 minus 76. Well, that would leave us with a negative 77x. We bring down our final thing to bring down, all the way down, this plus 4. So we got our negative 77x divided by x. X's cancel, so we just have a negative 77. So up here we just have our negative 77. Let's multiply it out. Negative 77 times x is a negative 77x. And a negative 77 times 2, that's a negative 154. And we subtract the whole thing. Negative 77x, and then we got those double negatives, which is really plus. So negative 77 plus 77 cancels. And 4 minus a negative 154, that ends up being 158. Okay, and I've got nothing else to bring down. Whew, that was a long one. So we're ready to write our final answer though. I've got my remainder, and so I want to go ahead and write my final top answer. So we got our 7x cubed minus 19x squared plus 38x minus 77. And then we write our remainder. So in this case, it's a positive 158. So we do plus 158 over x plus 2. And that would be your final simplified answer. we're going to do one final one together. So this one is not quite as long as this one, but again, notice we have a missing exponent. So we've got an x cubed, an x squared, and then we just go to our constant. So we're missing just our x to the first, just our plain x. We have to include it in our long division setup. So we've got our 5x cubed minus 7x squared, and then we need to include a positive or a plus 0x. Then we can continue with our plus 1. And then we are going to divide it all by x minus 3. So remember, it's 5x cubed divided by x. That would end up being 5 and then x squared. So we got our 5x squared. Let's multiply it out. 5x squared times x is 5x cubed. 5x squared times negative 3 is a negative 15x squared. We subtract the whole thing. So 5x cubes cancel. Negative 7x squared minus a negative 15x squared, so that becomes a plus. So negative 7 plus 15, that's going to give us a positive 8x squared. We need to go ahead and bring down our plus 0x. And we're ready to start the process over. So we've got 8x squared divided by x. 2 minus 1 is just an 8x. So we've got our positive 8x. Multiply it out. 8x times x is 8x squared. 8x times negative 3 is a negative 24x. We want to subtract. 8x squared minus 8x squared cancels, as it should. 0 minus negative 24x. So that ends up being a positive 24x. We bring down our 1. This is our last one to bring down. So we're going to do this process one more time. So 24x divided by just a plain old x. Our x's cancel, and we're left with just 24. So we end up with our plus 24. 24 times x is 24x. 24 times negative 3, that's actually a negative 72. All right, we want to subtract the whole thing. Our 24x's cancel, and then our 1 minus a negative 72, it's like 1 plus 72, which is a 73. I have nothing else to bring down, so I'm ready to write my final answer. So remember, it's this top row, 5x squared plus 8x plus 24. Our remainder, which is a positive 73, right? That was our remainder, over x minus 3. All right, here's one for you guys to try. I'll put the answer in the video description below. This has been Miss Math Tutorials.